Hello, assalamu alaikum, namaste, vanakkam. How are you, my champs? What's going on? So, yesterday we studied one beautiful and great topic, thermal expansion. From there, I said you can expect questions for NEET and mains. Okay, now let's get started without wasting any time. A single time, our problems. Okay, most important topics or most important types of problems that I have seen in NEET and mains. Okay, now let's get started. Okay, your question will appear here. So you need to write the question and answer. Okay, now let's start first question. See, first question is like this. What is the percentage change in length of 1 meter iron rod if the temperature changed by 100 degrees Celsius? Okay, now alpha for iron is given by 2 into 10 to the power of minus 5 per degree Celsius. See what they are asking now. There is one simple rod is there, iron rod, whose length is 1 meter. Now, if you rise the temperature to 100 degrees Celsius, we know there will be change in some length. There will be change in this length. Now, it is change in length. Now, we want this change in length in form of percentage. Percentage length. We want in form of percentage length. And you know one thing, to write in percentage length, what we do? We write percentage change is equals to rate of change divided by original length into 100. And what are all the things they are given? See, they are given length as 1 centimeter, and they are given temperature, and they are given alpha, which is linear coefficient thermal expansion. Linear coefficient thermal expansion, 2 into 10 to the power of minus 5 into degrees Celsius. Now here I want this value, correct? I have L value. I want change in L. So what I will do? I will calculate change in L, which I know formula, which has L alpha into temperature change. Correct? Temperature change. Now L value is, I know here 1 centimeter, they are given 1. Okay, and alpha value they are given as 2 into 10 to the power of minus 5. And change in temperature from 0 to 100 degrees Celsius, which means 100. Now if I do overall calculation, I will get answer like 2 into 10 to the power of minus 3, because it is 100, so minus 3 I can do. Now I will substitute this one here, then percentage of error is equals to 2 into 10 to the power of minus 3 divided by original length, which is 1 centimeter, 1 into 100. So overall I will get final answer as 2 into 10 to the power of minus 1. So if I write this in the form of percentage, then I will get 0.2 percentage. 0.2%. This is a change in our length. Okay, now take down first. I think it is over. Good. Okay, so let's get into the next question. Very soon. Next question. Next question is like this. See, this is one of the tricky question, but I will give best way to understand. See, there is a glass vessel of volume 100 centimeter cube is filled with mercury and is heated from 25 degrees Celsius to 75 degrees Celsius. What volume of mercury overflow? Okay. Right, now what they are saying now, there is a container, and inside this container I am keeping some mercury, and I will heat this. When I heat this mercury will overflow, this mercury will come out. What is the volume of mercury is coming out? They are asking. Okay, and they are given. See, they are given one thing. The volume of vessel they are given is 100 centimeter cube. Okay, and after that they are given rising temperature from T initial 25 degrees Celsius to T final 75 degrees Celsius. Okay, second hint. Then next, coefficient of linear expansion of gas. They are given coefficient of linear expansion of glass, which has 1.8 into 10 to the power of minus 6 per degree Celsius. And one more thing, volumetric expansion of mercury. They are given as 1.8 into 10 to the power of minus 4 per degree Celsius. Okay, fine. Now see here carefully. It is volume, and inside, when you fill mercury inside the beaker, that is also volume only, correct? Volume only. So, but here it is in the form of linear expansion. It is in the form of volume. So first I need to convert this into volume. How to convert this into value? See, in previous class, we have said there is a relation between linear expansion of liquid, volume expansion of linear expansion, volume expansion, and areal expansion. That is, see, beta is equals to 2 times of alpha, gamma is equals to 3 times of alpha. Correct? This you remember? Yeah, I think you remember. There is a relationship between alpha, beta, and gamma, which is like 1:2:3. Okay. Now, if I make this use, then I can write this as, see, I can write this as, how I can write? 3 times. Okay. 3 alpha, okay, gamma, okay. Let us ignore this. We'll write in a direct expression. Okay, fine. Now, if I come to final answer, I want this value, correct, which is equals to this one. And here we have expression as liquid minus container into change in temperature. Correct? Change in temperature. Now, sir, in this mercury glass is there, which is liquid, which is container. Mercury, which is liquid. So this will as liquid, and this is as container. Okay. Now let us start substituting here. V0 into liquid minus 3 times of alpha C. See, here we change into 3 because it is in alpha. I want in gamma. So what I will do, I will use this one. Okay. Now if I substitute all the values, then I will get 100 into liquid value is 1.8 into 10 to the power of minus 4 minus 3 times of 1.8 into 10 to the power of minus 6 into rate of change of temperature 75, which means 50. 50. Now if I solve this, I will get 0.87 centimeter cube. I will get 0.87 centimeter cube. Okay, now correct answer. Take one first. Take one. Okay. Fine. Super. Okay. Alright, next question. Go to next question, please. Okay. Next question, it is like this. Next question is like this, little heavy question, or you can say mains level of question. See, question is like this. In an aluminium sheet, there is a hole of diameter 2 meter and is mounted horizontally. Okay, now see what they are saying now. There is one aluminium sheet. Try to understand clearly. There is one aluminium sheet on which they have one hole. Here there is one small hole whose diameter is 2 meter. Okay, whose diameter is 2 meter. First part of the question. And then on this an iron sphere of diameter is 2.004 meter is resting. Okay, on this we are keeping one iron sphere whose diameter is 2.004 centimeter. We are keeping on diameter 0.04 centimeter. Okay, resting. Sorry, meter, right? Meter. Sorry, it is meter. A meter. Okay, initial temperature of this is 25 degrees Celsius. Okay, initial temperature they are given 25 degrees Celsius. And find at what temperature, which means we need to find final temperature. Find at what temperature the iron sphere will fell to the hole of the sheet. Okay, then coefficient of linear coefficient of aluminium is given as 2.4 into 10 to the power of minus 5, and our iron, which is given as 1.2 into 10 to the power of minus 5. See, now let us get into the question. There is one horizontal plate like this. On this, it is one hole. We are making hole. On this hole, this hole diameter is 2 meter. On this 2 meter diameter hole, I am keeping a 2.004 meter sphere of iron. Which means what happens? It will stay here only. It will stay here. See, it will stay like this. It will stay like this only. Like this. See, it is gap, but also staying because see, okay, it is like this. Now, if I increase temperature, then this will expand. If it expand, then this marker will go into this now. Similarly, there is one plate aluminium sheet which is hole inside. On this hole, I am keeping one iron sphere whose diameter is this much. Now, if I heat, this length of this diameter or this aluminum sheet will increase. When it increase, this diameter is also increase. When that diameter increase, then this sphere will go inside this. Now, at what temperature this will happen, we need to find. At what temperature this will happen, we need to find. See, when this ball enter into this, when it fit into this, then diameter of this sphere and diameter of this body will same. Correct, right? Correct. So, can I start with that only? See, can I start with diameter of hole is equals to diameter of sphere. Okay, I will start with this. Now it is changing, right? It is changing. After heating I am doing, right? After heating I am taking. So can I write like this diameter as, see, diameter, change in diameter, okay? Can I write change in diameter as initial into 1 plus alpha dou T? Yes, son, I can write. So if I write, this is, this is aluminium, this is iron. If I substitute all the values, then I will get, right, diameter of initial into 1 plus alpha dou T temperature into diameter of this one, aluminium here, Fe here, then 1 plus alpha dou T temperature. Now if I substitute 1 by 1 value, diameter of this one is 2 meter into 1 plus alpha of aluminium is 2.4 into 10 to the power of minus 5 into iron diameter is 0.4 into 1 plus alpha of this is 1.2 into 10 to the power of minus 5. Change in temperature. Sorry, I forgot change in temperature. Rebab. Okay, one second please. See, 1 second. Here I forgot change in temperature. Sorry for this. Here I forgot change in temperature. Initial temperature is 25. Change in temperature. Change in temperature is equals to diameter of this is 2.004 into 1 plus alpha. That alpha value is 1.2 into 10 to the power of minus 5. Change in temperature T minus 25. T minus 25. Okay, this I got. Now what I will do? I will just see. I will multiply this into this inside, or this I can write like this also, right? I can write this as of aluminium into T minus 25 is equals to 2 into 004 into 1 point alpha of iron into T minus 25 degree. Now this because I can substitute these values at the end, so that my calculation will be very easy. Now what I will multiply this inside. I will multiply this inside and I will send this to this side, and I will multiply this inside. Okay, now then what I will get? I will get as 2 alpha Areaial T minus 25 is equals to, if I send this that side and if I multiply here also, here will be 2.004 and this goes to then minus 2, then I will get as 0.004 minus of plus of 004 alpha Fe into T minus of 25. Correct? This one I will get exactly. Now finally what I will do, this one is looking same. So what I will send this at one place. So it will like 2 alpha Al, okay, now minus of 4 alpha Fe into T minus 25. Sir, what you are doing? See, nothing simple. I am sending this side, then minus will come. On this 2, I am taking this as common. Say this one I am sending here, minus will come. In this, I am taking this 2 as common. Then here it will be 0.004. Okay, clear? Now after that what I will do? I will keep T here. Then I will send all this downside. See, I will keep this one here and I will set this downside. Okay, now then I will get answer as T minus 25 is equals to 0.004 divided by 2 alpha Al minus of 2.004 alpha Fe. Correct, alpha Fe. Now what I will do? I will say just send this 25 into this side. If I send this 25 that side, then what happened? It will become like T plus 25. Okay. Now what I will do? I will substitute all the values. All the values means 0.004 divided by 2 into 2.4 into 10 to the power of minus 5 minus 2.004 into 1.2 into 10 to the power of minus 5, which equals to, I will get my, see, if I substitute, if I do this calculation, then I will get my final value as I will final value as 191.0 degrees Celsius. You do calculation, because in this time of calculation I will do you on some extra sum. Somehow I have these all values here, so I will do it directly. You do sums. This is one kind of illustration. You can call it as one kind of illustration. Very, very important based on the mains. Okay, take down fast. Oh, nice. Super. Fine, fine. Okay, alright, fine. We will run this. See, don't try to memorize any concept, because only one formula and we are rotating that formula. We know here it is only one formula, we are rotating one formula in all possible directions. Okay. Alright. Let's get into next question. Next question is very, very good, interesting question. Like this, see, a metal rod A of 25 centimeter length expand by 0.05 centimeter when temperature heated rise from 0 degrees Celsius to 100 degrees Celsius. See, okay, see, there is one metal called as A. There is one metal, let's say A metal. Now this metal, they are given some length. This metal length they are given 25 centimeter. Now when they rise temperature from 0 degrees Celsius to 100 degrees Celsius. Now they saw there is change in length which is 0.05 centimeter. Fine. Now similarly they took metal B. See, metal B, there is another rod B metal whose length is 40 centimeter. Expand to 0.04 centimeter on same temperature. There is one more length, let's say L1, L2, who's taken as 40 centimeter. When they rise temperature from 0 degrees Celsius to 100 degrees Celsius, now they saw that there is a change here is 0.04 centimeter. Okay, there is change here, this was 0.04 centimeter. Now third part, a third rod C of 50 centimeter length is made up places of rod A and B at the end and extend by 0.03 centimeter. Okay, on heating from 0 degree to 50 degree. Okay, 0 degree to 50 degree. Find the length of each portion composed of C. Okay, 50, 0.3, 50, 0. See, there is one more rod C whose length is, they are taken as 50 centimeter, which is rising from 0 degree to 50 degrees Celsius. It giving change as 0.03 centimeter. Now they are given one hint that this rod is made up of this one and this one, which means this rod C is made up of A and B. So what is this here now? See, if I take two markers to for your explanation, okay, this is marker 1, marker 2, or let's say metal 1, metal 2. If there is one small metal 1 whose length is 25, when I heat this from 0 to 100 degree, this length increase, this length increase, this length increase, like this length is increased, one metal. Now there is one more metal whose length is 40 centimeter. When the rise temperature from 0 to 100, now this length also increase. Okay, two different methods. Now what I am doing, third metal, I am combining this metal and this metal, which means I am combinedly taking these two metals. See, combining these two metals. If I combine these two metals, then if I heat from 0 to 50 degree, it is also expanding. It is also increasing, expansion. Okay, that expansion they are given 0.02 degree, and what they are asking, what amount of metal A, metal B used in this, which means, see here length, what is this length, what is this length, they are asking, or what amount of A and B used they are asking, which means they are asking what amount of L and what amount of 2 they are asking. Okay, fine. Question understood. Now let us start with the answer. See, first of all, basic thing. Here one good thing is last one. It is combination of these two. So what I will do? I will write L1 plus L2 is equals to 50. Correct? L1 plus L2 is equal to 50. And after rising, it is changes to 0.03, which means there is change in this one, which rises to 0.03. 50.0. Oh, sorry. Array, 1 second. There is a small mistake. Array, it is final length they are given, which means final length. Sorry, I am not taking the 0. Final. Which means after rising, I am getting 0.0 the extension. So final length of this one, final length, initial length of this two, 50 centimeter, and final length of this two, if I heat temperature, both will increase. So this will increase. Now understood. Okay, why I am writing square? I'll take as cash. Now rate of change. Rate of change means what? This one. Rate of change. Rate of change is 0.03. Rate of change. It is 50, 0.03. Rate of change is 0. See, remember one thing. It is initial length made up of this one and this one 50. It is final length made up of rise in this, change in this, change in this. It is change of. Okay. Now let us take this as 1. Now let us use this and get one more expression. Like, this one I will write as L1 into alpha into dou t plus L2 into alpha 2 into dou t is equals to 0.03. I can write like this. Okay. I have length L1. I have dt for this one. Say length we will take this one. Sorry, one second. What I am saying. Length we are calculating, right? Sorry, length how we will take? Sorry. Okay. See here, my kids. One rod, mix up of two rods. We need to find L1 and L2 in this rod. What I will take? I will take first L1 plus L2 is equal to 50. This rod is made up of this one and this. Okay, side by side. Okay. Now, after I heat this rod, increase the length this much, which means there is change in this one, there is change in this one. Okay. Now, that amount of change is the change is 0.03. Now, this one I will write as this one, expansion formula. Now, I need to write L1 and L2 from this. I don't have this also, but I have this. How to do? See, I want coefficient of linear expansion now. I can use this to calculate coefficient of linear expansion. How means, if I use this one, focus on this one. If I use this one, here change in length is equals to original length into alpha into dou t. For this one I am doing. For this one I am doing. Okay. Here change in length is 0.05. If I send this one and this one downside, then original length is 25 and temperature is 100 is equals to, correct, alpha 1. Now if I solve this one, then can I write this phi as 50 into 10 to the power of minus 2? Yes, I can write. And downside 150. And if I send this 100 upside, it will become 10 to the power of minus 2. Correct? 10 to the power of minus 2. Now 51, sorry, one thing, it is 3. 1, 2, 3. Now it is clear. Now 51, 52. I will get as 2 into 10 to the power of minus 5. Correct? I can write like this. So I got 1 for this value, I got is equals to 2 into 10 to the power of minus 5. For 1 I got. Now let us same way, let me find for second also. Let me find this one also. So how to find that one? I will use this one to find this one. How? See, same. Okay, dou t change is 0.04. Divided by this I will send downside, then 40 into 100 temperature is equals to, right. Then I will solve this one. Can I write it as 40 into 10 to the power of minus 3 divided by 40 into 10 to the power of minus 2, which means I am sending this to 100 and I am shifting this point from here, and one more. So 1, then I will get final answer as 10 to the power of minus 1, which means for this alpha 2 value is 10 to the power of minus 1. Clear? Alpha 2 value is 10 to the power of minus 1. Okay. I got for this alpha value. I need to calculate this one, and change in temperature is this. See, we are taking change in temperature this 0 to 50 because we are calculating mixed one. It is, see, this 2 is given to confuse you and to find this value so that you can substitute in this. Aha, so talented, so talented. Okay, L1, alpha 1 value is 2 into 10 to the power of minus 5. Rate of change of temperature is 0 to 50, which means 50 only. 50 plus L2 of alpha value 10 to the power of minus 5. Change of temperature is 50. 50, which is equals to 0.03. Alright, fine. Now see here, this one and this one is common in this both. This one is common. So can I write as 2L1 plus L2 is equals to 0.03 divided by 50 into 10 to the power of minus 5. 50 into 10 to the power of minus 5. Yes sir, I can write this. Then I will get 2L1 plus L2 is equals to 0.03 into 10 to the power of plus 5 divided by 50. Now if I solve this, how much I will get? 50, okay, 55, okay, can I write 0, 550 divided by that is 60, 0.06. Okay, see, I will get answer as something like I will get 6. Am I getting like 6? Okay, I will get answer as 60. See, how means now? Very simple. Do one thing. Send this 0, send this point from here. Make upside as 300. Like 300 into 10 to the power of minus 4 into 10 to the power of minus 5. 300. 1, 2, 3, 4. Okay, 4. Divided by 50. 50 ones are 56. See, here 50. 50 ones are 56. Sorry, 56. Then you can get 60. Okay, now you will get 60 answer. Which means totally we got 2L1 plus L2 is equals to 60. Alright, fine. Now same thing, see here, L1 plus L2 is equal to 50, L1 plus L2 is equal to 60. Now can I solve this both and get final answer? Okay, let's get started. Let's get solve this and get our final answer. How? First expression and next expression is 2L1 plus L2 is equals to 60. Now this is our second expression. Now can I write as like this? How can I write? Oh sir. Can I write like this? If I write like this, this both will cancel. Then here it will remain as minus L1, correct? Minus 2 plus 1 is equals to, here it remains as minus 10, which means L1 is equals to 10. If I take L1, if I substitute in any option, then I will get L2 as 40. L2 as 40. I will get L1 as 10, L2 as 40 centimeter. Which means this third rod is made up of, which is mixture of first rod and second rod. First rod is 10 centimeter, second rod is 40 centimeter. Like what I said here, this one is 10 centimeter, this one is 40 centimeter. Oof. Such a good question, really good question. We can expect this for this mains, JEE means 2025. You can either in April or either in January, it will 100%. Okay, try down first. Okay, student. So let's get started with the next question. I hope you understand this question. Yeah, I know, little high level question, but I think you got it. Alright, next question is still more very good. Now this question is like this. Wait, 1 second. Alright, see the question, please. See, two straight thin bar, one of brass and one of steel are joined together side by side by a short steel cross section, okay, at 0 degrees Celsius, 1 centimeter. See what they are doing now. They are taking two metals, one brass metal, and on this brass metal they are one more metal, steel metal. One more metal, steel metal. They are adding like this. Okay, now on this they at every 1 second, 1 meter, every 1 centimeter, they are keeping like this steel attachment. See next part of the question. Now together side by side by short steel cross plate at 0 degrees Celsius, 1 centimeter along. See, they are saying this, they are keeping 1 centimeter. They are keeping 1 centimeter steel one. STE steel. This is your brass and this is your steel. See, this simple. They are taking two metals, keeping one above other, steel and brass, and together they are joining by use of this steel compartments. This steel length they are given 1 centimeter. Now, next part of the question is like this. After this, these all at 0 degree Celsius. 0 degree Celsius. Okay. When the center lies of bar being 1 centimeter apart. Okay. When heated to 100 degrees Celsius, when I am heating this to 100 degrees Celsius, what happening? The composite bar becomes bent into the arc of circle. This composite bar, it will start bending like this. It will start bending like this. It will start bending like this. Okay. Let me take this as A, this as B, and this as C, this as D. Okay. Bending. After bending, what happened? The composite bar bend into arc-like circle. Calculate the radius of circle, which means if it is fully bent, then it will form one circle. Now, that time your radius will be here, right? Here radius. Here radius. You need to calculate this R value. This R value. Anything hint they have given? Yes, they have given one more hint. As, see, they have given as one hint, alpha of steel. Alpha for steel. ST, okay, 1 second. Okay, yeah. Brass, they are given as 19 into 10 to the power of minus 6 per degree kilo. And one more for steel, they are given as 11 into 10 to the power of minus 6 per degree. Okay, fine. This is, please 1 second, don't mind. And here we have our large compartment, 1 centimeter. Okay, fine. Okay, now see what is the main thing now? We are keeping these two metals with the help of steel brass. One steel, one brass. We are keeping like this. We are keeping like this. Now we are joining this both. If we join this both with the help of steel, okay, good. And we are heating. When we heat, this started bending like this. It started bending because 1 second. One minute, please. Sorry. Okay, now it bend. When it bend, it make an arc-like structure. If this arc is full, then it will produce one circle which has radius r. Now it is very r. That time this r value we need to find. Now, so why it is bending? Because see these two values. Linear coefficient of brass is more than steel, which means what? See, linear coefficient, where is expansion? Change in your length is directly proportional to your linear expansion, right? Alpha. Directly proportional to alpha, right? So whose alpha is more, their expansion will be more. Okay, now here brass alpha is more compared to steel alpha. So it will bend. Okay, now we need to find this. How to find this? See, before you find, I will tell you one thing. This is also steel. Steel. Now when you heat, this steel will also expand. Correct? When you heat this steel will also expand, which means whatever here, it will be more than this. Correct? Which means this will also have some area, AC. So I need to find this, let's say angle theta. Say one thing, if I am clamping steel here, if I hit overall, then this will also bend and this steel will also expand. Which means here this is also expanding. Overall this is like this, then it will expand and cut. Okay, now that time, if I calculate this expansion, it will be very useful. Okay, how? Let us come. See here AB is brass, AB is brass and inside is steel. Alright, fine. Now let me come into main thing. Let us calculate AC value. Change in AC. 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 Okay. To calculate AC value, what I can do? See AC value, length, first of all length they are given. Okay. And we are going from 100 to D. Okay. Which means change in AC can I take as L into 1 plus alpha into rho T. Okay, which means length is 1 centimeter they are given, which means can I write 1 into 1 plus alpha value, it is also made up of steel, so I will take this only, steel, so 11 into 10 to the power of minus 6, change in temperature is 0 to 100, so 100. So what I will get, 1 plus 11 into 10 to the power of minus 4, 1 plus 11 to the power of minus 4. So for this, how can I write? Okay, but I will do my simple thing. Can I write it as 0, 0, 0 into 10 to the power of, oh yeah, one thing, some small thing. I'll write it as one more 0 into 10 to the power of minus 4 plus 11 into 10 to the power of minus 4. Now I will get as 0, 0, 1, 1 into 10 to the power of minus 4. So if I cancel minus 4, then I will get as 1.0011. Alright, so this is simplified method I am doing, or else we can do from here only, but I am doing very simplified because I am very happy with this. So what we can do is now still it is like 1 plus 0.0011. You write, add it 1.0011. You got your answer. But here I am doing two methods, whichever you can use. So here change in length, AC value we got is this one, 0.00. Okay. Take note this. After heating AC value becomes this. After heating AC value becomes 1.0011. Fine. Super. Very good. Now expansion. Let us come to directly expansion. Now arc formula. It is this much length increase. It is small length increase. So can I say this full AB? Is equals to AC plus R into theta, and CD is equals to R theta. I can say like this. Can I say like this? Yes, sir. Of course you can say like this. Okay, then why you are making? Take note. Why you are making? Time waste. Take note first. If I write like this, then if I substitute one by one values, which are the values? If I substitute these values, then let me see what will happen. And at one point both will be same because both are bending now. So it will be same. Wait, take note first, please. Okay, fine. Now let me start by one. Okay. AB value, which is equals to AC value, which is 1.0011 plus R into theta. CD value is equals to R into theta. Make it as option 1, make it as option 2. Sorry. Okay, fine. Take it. Now, after that, what I will do now? Can I write this AB as like this? AB as L1 into 1 plus alpha into rho t, and CD as L1 into 1 plus alpha into rho t. Yes, sir, I can take, because at the initial length of this one is same. At the initial length of this is L1, length of this is L1. Both are same. I can write like this. Or no, please take note. This as, mark this as option 3, mark this as 4. Alright, please take note first. Right. Now after that, let me clear this. Once if I clear this, then come on. Now divide AB by CD. Now I can divide by two methods, one this one and one this one. Let me check both. So first one, let me take as R plus 1.00 into R theta divided by R theta, which is equals to this one, which is equals to L1 plus 1 plus alpha into rho t, which is divided by L1 into 1 plus alpha into rho t. This is AB. AB is for brass, this is for brass, and this is for steel. Correct. This is for steel. Now I can cancel theta, this one from here. Then I will get as R. I will get as R plus 1 into 0011 divided by R is equals to 1 point. I will substitute brass value here. which is 19 into 10 to the power of minus 6. Change in temperature is 100 divided by 1 plus, and still value 11 into 10 to the power of minus 6, and change in temperature is 100. Now even I can cancel many things like this one, this one, this one. If I cancel all this, and moreover I can write here 1 plus 0, 0, 1, 1 into R is equals to 1.19 into 10 to the power of minus 6 into 100, or I can write it as 10 to the power of minus 4 divided by 1 plus 11 into 10 to the power of minus 4. Now this is here no more needed. Here we need no more. Radius vector. Okay, we calculate radius vector. Radius is here only. So what I'll do, I'll just send this that side. R is equals to 1 plus 19 into 10 to the power of minus 4. Then minus of 1 minus 11 into 10 to the power of minus 4 divided by 1 plus 11 into 10 to the power of minus 4. Don't get confused. I just send this to that side. If I send plus 1 to that side, minus 1 will happen, and I multiply this one with that. Okay, now fine. Then 1.0011 divided by R is equals to minus 1 plus 1 cancel. Then 19 and 11 is there, which becomes 19 minus 11, 8. 8 into 10 to the power of minus 4 into 1 plus 11 into 10 to the power of minus 1. Alright, fine. Now I will rub this side. Okay, peacefully if I calculate this, then I can write R is equals to 1.0011, which is equals to 1.11 into 10 to the power of minus 4 divided by 8 into 10 to the power of minus 4. Alright, now I can do it as 1.11 into 10 to the power of minus 4 into 8 into 10 to the power of minus 4 into 1.0011. If I calculate all this R, then I will get my final value as 1252.8 centimeter. Again, this I will get my final. But take it first. See, very simple. Two materials of different alpha value we are heating. When we heat, it bend. But one thing we are taking is we are taking steel rods to make connection of these two metals. Okay, that's all. And that radius arc we are finding. Okay, take note first. Alright, fine. It's over. Good. Alright, let us get into next question. Now, next question it is like this. Next question is a clock with a metal pendulum. There is a clock with metal pendulum. You know, they are talking about the metal pendulum clock. There is a clock with metal pendulum in 5 seconds faster each day at temperature 50 degrees Celsius, and 10 seconds slower each day at temperature 30 degrees Celsius. Which means they are saying that at temperature 15 degrees Celsius, see, when temperature is 15 degrees Celsius less, then it is 5 seconds fast. 5 seconds fast. Now, when your final temperature is 30, say, when final temperature, 15 degrees, then 10 seconds slow each day at temperature 30 degrees Celsius. Which means at 30 degrees Celsius, which is less than our room temperature, it is 10 seconds slow. Okay. Now what we need to find? Find the coefficient of linear expansion of metal. Coefficient of linear expansion of metal, which means we need to calculate this one. Okay. See here what they are saying. There is one pendulum watch or pendulum clock whose, when we have high temperature, now when temperature is 15 degree, when we have temperature less than our room temperature T, if I take room temperature as T, if temperature is less than this temperature, then it will be 5 seconds faster. And if it is 30 degree more than the room temperature, which is difference more, then it is 10 seconds slow. Then what is that pendulum alpha value? Okay, you know one thing. See, rate of time duration or lag of time or change in time or per second change in time, half is equals to alpha into dou t time. Correct? And see, this comes like this now. And for 1 second, it is change in time. It is change in time or duration or lag in time. For 1 second or change in for 1 second time, we write as for 1 second. I am talking only about 1 second. For 1 second, we'll write as this one. Dou t is equals to this one. Again, for 1 second. Okay. For 1 second, it is this. For 1 second. For 1 second. For 1 second. Okay, fine. Now, is there any hint? Is there any one more hint in this? No. Okay, fine. Now it is every second. Now it is for 1 day. If I take, it is for 1 day. If I take here, if I take for 1 day, how many seconds are there in 1 day? From temperature is T to 15. If I take first case, and in 1 day, how many seconds? 1 day is equal to 24 hours, 24 to 60 minutes, 60 minutes is equal to 60 seconds. So overall, my number of seconds will be how much? This much second. For every second, how much time is changing? For every second, see, for 1 second, the time changing is this much. For overall day, time changing is this much. Overall seconds. Okay, now overall seconds. Now. Okay, fine. This is for one thing. This is for one. Now there is one more they are given. There is one more. What is that one more? Okay, here, change in interval for next two, which is half alpha, same metal, right? Same metal, 30 minus t into 86400. 86400. 86400. Now they are saying here it is 5 seconds faster, which means it is 5 seconds faster. Change in temperature, change in time is 5 seconds. Correct? Here lag of time is 10 seconds. Right, fine. We got two expressions. See, here we need to find psi value. Okay, we will find this. We will find this. Okay, come on. Let's get started with the one by one value. See, can I write this both as like this? If I multiply here, 10 is equals to alpha into t minus 15 into 86400. Here 20 is equals to alpha into 30 minus t into 86400. Okay, fine. Now if I compare all this both, it has 1 and it has 2. Okay, fine. Now if I compare this both on upside, can I write second equation as this? See, 10 into 2, 10 into 2, okay. Second equation as 2 into 10 is equals to alpha 30 minus t 86400. Okay, I will write third equation. Now what I will do, in the place of 10, I will substitute all this. In the place of 10, I will substitute all this. So, tau is equals to alpha into t minus 15 8644 is equals to alpha into 30 minus t 8644. See, 8644 I can cancel. Then I will remain with 2 alpha t minus 15 is equals to alpha 30 minus t. Okay. Now if I do simple multiplication, then simple calculation, then I will get it as what I can do this 2 alpha t minus 30 alpha is equals to 30 alpha minus of alpha t. If I do this, then I can cancel these two. Then hey, 1 second. What I am doing? Alpha 30 alpha. Array plus ra. Both are plus. Okay, both are plus. Then what happens? Here 2 alpha t plus alpha t is equals to 60 alpha. Okay, alpha 3 which is equals to 3 alpha t divided into 60 alpha. 3 alpha will cancel, right?
fine, alpha get cancelled. Then I'll remain with T is equals to 60 divided by 3, which like 20. Okay, I find temperature at 20 degree. At 20 degree, we find temperature T. Now what I will do, I'll just take this T, I'll substitute here. I'll just take this T, I'll substitute in this. Then 10 is equals to alpha into T value is 20 minus of 15 into 86400. If I solve this, I'll get 10 into 5 alpha into 86440. Now if I want alpha, I'll very easily sum. Alpha is equals to 10 divided by 5 into 86440. So if you do overall calculation, you will get alpha value as 2.31 into 10 to the power of minus 5 degrees Celsius. Do this. Write overall alpha value this much. Okay, fine, perfect sum. Perfect. Fine. Okay, students. See, there are still more sums are there. Once again. There are still more sums are there, but we'll stop this here because already it has been 1 hour, I think so. So we'll continue this in next class. Maybe we'll do some sums. Then again we'll start a new topic. Okay. Till then, take care. Bye bye. Shabakya. Okay. Love you.